is having around 21 years of teaching experience. He was awarded with PhD in mining for web engineering from Sri Venkateswara University, Tirupati. Presently, he is working as professor in CSE Department, MVSR Engineering College, Hyderabad. He worked as a professor in KL University, Vijayawada. He is a recognized research supervisor for JN2 Hyderabad, OU, and KL University. He is acting as an academic council and BOS member at KL University. He published research papers in 32 international journals and 15 conference papers, proceedings, etc. Dr. Krishna Prasad Garu has also published 3 books, 3 book chapters, and 4 patents. He is acting as an editorial board member and also received a gold medal as a best teacher at MIPGS in the year 2003 and also in the year 2005. It is a great honor, sir, to have you as a speaker for today's session. So I'll hand Masha, sir, please.
Okay, thank you, madam.
Thank you.
Thanks for giving the opportunity to share my knowledge. Okay, I will start the session. Is it my PPT is visible? Hello?
Yes, sir. Yes, sir. Yes, sir. Visible, sir.
Okay, sir. Thank you.
Yeah.
Okay, this is second day.
Yes, sir.
So yesterday, I think introduction to R programming, few concepts related to the R commands, input-output statements, control statements, these completed. Today, I will concentrate on descriptive statistics, statistical analysis part majorly. So before going to demo on descriptive statistics, we will see few concepts related to the theory part. So the main objective of the session is basic knowledge and data analytics, usage of our software, descriptive statistics, developing analytical projects, give some thought provocative ideas. This is the main objective of the session. So you know very well about the data analytics. So introduction part I'm skipping. So you know data analytics, a combination of computer science, mathematical statistics, and its applications. It's an interdisciplinary course, interdisciplinary subject. So previously, before this analytics usage, what is the word we used? Data analysis or statistical analysis. These are the two words. Present day analytics is the buzzword that we are using. Then what is the difference between data analysis and analytics? So data analysis, whatever the data is there, that we need to study, understand, and convert into a knowledge and usable format. Analytics is also a process of data analysis, but automation of analysis and making guide to the decision making process, we call it as analytics. So analytics include both data analysis and communication to the end user. Who are the people going to be involved in decision making? Generally top level people only. You take any business or a business organization point of view, or any family point of view, or any educational institute point of view, top level people, or CEO, or managing director, or management committee member, or principal, those people are going to be involved in decision making. So analytics means data analysis and communication, guide to decision making. Simple example. View of data. Suppose student ID, passport ID, vehicle number, Aadhaar card number, PAN number, what we call. Can we say these are intelligent keys? So what is the meaning of intelligent key? Any one of you, please. Intelligent keys. So generally, if we take any table, table consists primary key. Primary key is used for identifying the record, specific record. These not only primary key, these are also some hidden patterns are there. Just you observe simple, even student ID. Student ID also consists some hidden data. Hidden data like student admission number, year of admission, branch of admission. So even in the passport also some information is there. Even vehicle number also some information is there. It's related to the which state, which area. In each and every intelligent key have some hidden data. That hidden, identifying the hidden data and converting that hidden data into most useful format is nothing but a analytics. Any data you take, identifying the hidden data and converting into most useful form. That is nothing but data mining, data analytics. These are all similar words. So you know the meaning of data. Data, it may be computer science point of view, character, integer, real. In this way we are going to use, but statistical terminology point of view, it's different. Terminology going to be changed. It is created continuous. Ordinal variable, categorical variable, nominal variable. In this way, terminology going to be changed. It may be either univariate or bivariate or multivariate. But present day, recent trending point of view, we are going to compete with unstructured data. We are taking the web data also, RFID data, web term data, data consumer preferences, symbols, social media data, like, dislike symbols, smiley, angry symbols. These are all part of analysis. So if we want to do some analysis on structured data, you can easily work out. If it is unstructured data, how you are going to handle it. These are the things related to the data science problems. So here, if it is data is in structured form, am I audible?
Yes, sir, you're
Hello?
audible.
Audible, sir. Audible.
Yes, sir.
Okay. If it is a structured data, how you are going to see? If it is unstructured data, how you are going to see? These are all matters for performing analysis part. If it is a structured data, it may be either one-dimensional or two-dimensional, multi-dimensional format. Generally, it may be array or list table in this format. See, suppose a two-dimensional table is there with value, city, time, total revenue. How you are going to see? For easy understanding point of view, you can convert this into a two-dimensional table form. Row header with the column, row header and the column header. So just you observe, a table is converted into a row header with and the column header point of view, and reducing the number of rows for easy analyzing, understanding point of view. So how we can convert this table into a two-dimensional? Here also normalization plays important role. Normalization theory. Which row, which column I need to choose as a row header, which column I need to choose as a column header, which column I need to choose as a cell value. These are all matter. Suppose if it is 3-column data, if it is 4-column data, how you are going to see? If it is 5-column data, 10-column data. If it is 4-column data, we can see a cube structure form. If it is a 5-column data or 10-column data, so in that, if more number of columns are there, we are trying to identify the most featured attributes, most important attributes, with that attributes, we are trying, on that attributes only we are trying to convert creating cube and querying out. So generally, a two-dimensional data, multi-dimensional data, it's okay. In recent trends, you can see high-dimensional data. What is the meaning of high-dimensional data? Here, a high-dimensional data refers to more number of dimensions, more number of columns. When compared to the rows, here sample size may be 10,000 records, 10,000 records. Even columns also more than 10,000. In that case, how we are going to handle it? If it is 10 columns, 15 columns, 100 columns, okay. If columns also, number of columns are also more, how we are going to handle it? So these type of things comes under high dimensional data. If it is number of parameters are more than the sample size, that means P is greater than N. N is the sample size, number of records. So generally statistical terminology N refers to observations, number of observations. But our computer terminology we call it as a record. P parameters, attributes. If P is greater than N, whatever the statistical formula is there, that statistical formula also not applicable. Simple example, chi-square test. Chi-square test denominator is n minus p minus 1. If p is greater, this whatever the chi-square test formula is there, that is not applicable for high-dimensional data. In the same way, for unstructured data or for high-dimensional data, whatever traditional statistical formula is there, that's not applicable. So here, research plays important role. So any researcher finds new formula, it will be added advantage. So big data, this, whatever the data is there, it is unstructured and continuously increasing, and you are not able to handle with the traditional data tools. Those things comes under big data. Here, big data refers to with the traditional tools, traditional database tools, if you are not able to handle those things, we call it as big data. Because different textbooks, different authors says different definitions, even though overall meaning is beyond the ability of typical database software tools to capture, store, manage, and analyze. So, big data point of view, several properties are there. 3 P's, 3 V's, velocity, variety. In this way, so as per the big data blog book point of view, 4 properties. One is it is data is continuously increasing. It may be the structured or unstructured, difficult to analyze within certain tolerable time limit. This type of data we call it as big data. For handling big data, you may require big data tools, big data softwares like Hadoop, Spark. In this way, several are there. So present trends point of view, different types of data, it may be treated, it may be comes under as either big data, or data analytics, or data science, whatever may be. Different data. So end user point of view, how you are going to see the data, that is most important. How we are going to see the data, that is most important. So end user, who are the end users? Generally, data analytics point of view, data science point of view, end users comes under, end users are top level people who are involved in decision making. Simple example, even customer is also end user. When a customer is end user, if customer is buying to, trying to purchase some items, so customer is in, customer trying to take some decisions, which portal I need to use. which shop I need to use, which item need to use, either customer or skilled person or top level people, whoever may be end user, those who are involved in decision making, those people we call it as a data analyst and data user, end user. View of data, it may be different perspectives. Simple example, one idle is there. Based on the previous known things, we are able to draw some conclusions. We are able to draw some inferences. Suppose a person knows only Vishnu is Vishnu idol. A person knows Narasimha Swami is going to treat as Narasimha. In this way, if doesn't know Vishnu and all other names, so is treated as this idol related to one. So in this way, depending on the previous known knowledge also, previous known data is also important in connecting and inferring and drawing conclusions. So these most important. So what are the two types of statistical analysis? I think previously we discussed, in previous session we may discuss that is the statistical analysis point of view, descriptive analysis, predictive analysis, descriptive analysis, predictive analysis. But analytics point of view, these changed. Descriptive analytics, diagnostic analytics, predictive analytics, prescriptive analytics. Here, descriptive analytics, these two similar. In the middle, in previous statistical terminology, statistical analysis also one part is there that we call it as a root cause analysis. That root cause analysis stated as a diagnostic analytics. Predictive analysis or forecasting, estimation, predictive analytics, these three are similar, these are all similar. And analytics point of view, one more is there, prescriptive analytics. How to make it happen? Based on the previous history, based on the predictions, we need to convert into how to make it happen. Prescriptive analytics. If you see recent technical papers, recent research papers, apart from this four, one more also is there. Can anyone of you name that? Apart from these four analytics, types of analytics, one more analytics is there. Recent papers added. That is cognitive analytics, adding sentiments. So next one is cognitive analytics. So these are the four different types of analytics. Descriptive analytics, diagnostic, it's related to the root cause, why it happened. Predictive analytics, prescriptive analytics, you may add, that is cognitive analytics. In recent textbooks you may not find, but technical papers you may find, that is cognitive analytics. So different types of analytics you can see: high dimension analytics, big data analytics, cloud analytics, IoT analytics, business analytics, web analytics, mobile analytics, predictive analytics. Here, database point of view, how you are going to categorize based on the type of data, based on the architecture, based on the technology you are going to use, based on the model you are going to use. In the same way, here also you can choose n number of names based on the technology, based on the model, based on the type of data. Mobile analytics, cognitive analytics, self-analytics. Even in our day-to-day life also, we can use this analytics, self-analytics. So these types of analytics. So our as per the organizer's point of view, I need to discuss on descriptive analytics, statistical part, descriptive statistics, statistical analysis, descriptive analytics. Descriptive analytics. So descriptive analytics refers to analyzing, understanding whatever the data is there that we need to understand. Then we can convert into a usable form. So predictive analytics, one option. Next level, forecasting point of view. Prescriptive analytics. So here you can use this, how to make it happen point of view, optimization algorithms or machine learning algorithms. This we can use and convert into prescriptive analytics form. So these advanced analytics. Descriptive analytics is a operational analytics. Descriptive analytics, operational analytics, simply understandable, understanding. So this we call it as our operational analytics. Next level is advanced analytics. By using this transaction processing, by using this understanding, you need to convert into a next level that is called predictive analytics. So in this predictive analytics, you may use statistical predictive models like regression models, auto-regressive models, binary regression model, multiple regression model. Next level is prescriptive analytics. There you can use machine learning, deep learning, neural networks. Next is cognitive analytics. There you can use self-learning. That means bot creation, enterprise application, artificial intelligence, cognitive computing, creating intelligent robo. This comes under advanced analytics. So till now, these concepts discuss what is data analytics. Data analytics refers to combination of analysis and communication. Basic requirements to be data analyst, that this I am skipping. Education point of view, math, stats, computer programming are this required. Visualization, career options, business analyst to data analyst. This is several jobs categories there. Data engineer, data scientist, marketing analyst, information security, quantitative analyst, statistician, different names, different roles. But our basic course point of view seems to be data analyst to business analyst. These two, you may feel that these two are equal, but these two are not equal. Their job profiles are different. Business analyst job profile is short term. Data analyst profile, data analyst view is long association. Overall, the enterprise data treated as data analyst. So their roles, if you want to understand more about data analytics, my suggestion is you see the job opportunities related to the data science or data analytics. Based on their terminology, based on their roles, we can understand what is what. What are the concepts involved in data analytics? That also we can highlight, we can understand. So industry usage point of view, in all the places, healthcare, government, all the places we can use. Retail, telecommunication. Technology point of view, most of the places, most of the companies, MNCs are using R and Python. R and Python. Visualization point of view, Tableau also using. Email recently one project I have seen, that is email analytics. Generally, sometimes we are going to see the chain of mails. Continuously, maybe 100 mails, sometimes on particular topic, 100 emails or 20 emails we are going to get. So instead of going through the 20 emails or 100 emails, summary of that all mails. So email analytics. So in this way, different ways, in-memory computing, blockchain in data analytics, IoT analytics. So overall, data analytics importance given to the business analytics. Why we are giving importance to the business analytics? So here we need to see the history of business. Then we can understand why analytics is important in business. What is the history of business? Any one of you, please? How business evolved? In olden days, analysis or analytics is not required in business. Now required this analytics role. Why it is? You observe business, its product view started with exchange of goods. Next level, money involvement, suppliers and customers. So their actors are only two. If actors are two members, there is no requirement for analyzing. Next level, managerial view, 20th century, suppliers, customers, owners and employees. So their involvement, four actors. Business intelligence view, 1960s, 1990s, competitors, government and environmental view. That means business point of view, it may be either fixing the price or inventory point of view, anything. Business launching, product launching point of view, for all this, more number of actors are there. You observe next generation business intelligence, suppliers, customers, employees, owners, news, communication, social media, multinational companies, all involved. So whenever more number of actors involved, their analysis plays important role. Analytics plays important role. It may be pricing, customer segmentation, whatever. So business analytics point of view, data is there. This data, how we are going to collect the data. This is a simple diagram, shows the data analytics architecture. So this first level comes under data sets, different data sets. Even you can find this type of architecture in a data warehouse building process also, ETL architecture, data warehouse building. So data may be in different forms or maybe structured form. So you collect and convert into a common form and storing in data warehouse, or maybe data container, or maybe a data mart, some place you are storing. So from that, if you want to access effectively, you required the data should be in different formats. You observe general terminology, how we are going to store the same way we can retrieve. if we store the data in sequential fashion, we need to extract in sequential fashion only. In database terminology, and while studying database itself, we know these concepts. If you store the data in a tree-structured indexing format or hash-based indexing format, we can retrieve effectively, efficiently. So storage mechanism, storage pattern is most important for effective accessing. So that's why whatever the data is there, that data we are storing in different formats with indexing, with cube structures, with multidimensional structures, and creating snapshots, creating views, generating reports, automatically updated reports, personalized dashboards. So from once you store the data, from that to end user point of view, that we call it as a front room access. Front room access. So there analytics plays important role, visualization plays important role. Whatever the data is there, that how we are accessing, how effectively we convert into a end user understandable form. So there report generator, data miner, visualizer, statistician, data analyst, all plays important role. So our focus is data set is there, that how we are going to convert into a end user understandable form. So for that point of view, R is one of the statistical analysis tool. Python is for background process point of view started. Now without R also, by using Python itself, you can build Python started with a background supportive, not for front-end supportive. But later, now Python contains back-end supportive as well as front-end supportive. Front-end related, all types of functions are also able to handle by the Python. So by using Python itself, you can do all entire process. Even R started with a front-end process, statistical tool evaluation part. Now even R entered into backend supportive also. R software is able to handle backend data pre-processing, data processing, data capturing different capturing mechanisms from R. So R is a single tool without using third-party tool. With a single R itself, by using R itself, you can start building the data, constructing the data, and evaluation, analyzing, visualization, everything from R also. So by using single R also, you can use for enterprise resource planner, even Python also you can use. So now we focus on R. So already yesterday with Dr. Oblesh garu shown installation of R commands, these things. For software project.org, R Studio. For basic learners point of view, you can use rtutor.com. For middle level programming point of view, you can use for scripts, datacamp.com. You can use. My favorite tool is favorite portal is analyticsvidya.com, and another one is towardsdatascience.com. Generally, whenever I'm free, I'm going to browse analyticsvidya.com, and another one is towards data science. These two my favorite portals for learning data science or data analytics part. So generally, if you want to learn any new language or new concept, we are trying to map from the previous things, previous known to unknown. Simple example, so suppose now you are trying to learn R programming. If you want to learn R programming, for easy remembering point of view, easy understanding, easy learning point of view, you map with the previous known programming language. It may be either C or Java or C++ or Python. So generally, suppose most of the students, most of the faculty are familiar with the C program. So in C program, what is the program structure? How we are going to use the comments, syntaxes, execution part, what are input output statements, what are the different types of data types, control statements, arrays, structures, functions, files, whatever, all you list out R programming concepts, all R programming concepts you list out with that header, you can easily remember. You can easily work out. So here also comment point of view, R programming hat symbol you can use. Data storage elements, constant variables you are going to use. Here also you can use vector in R programming. Most of the things, most of the data we stored in the form of vectors, list, arrays, data frame, matrices, table. Here data types, different types, IO statements, just like there, here also scan, write, print, control statements, here also control statements like here easy, more syntax, easy representation available in R programming. So this we'll see later. Now we'll move to R Studio. So you know very well about the R Studio environment. Generally, for R software point of view, you require R two softwares. One is R software, another one is R Studio software. R software is for command interpreter, text based. So to add GUI functionality, GUI facility, we required R Studio, or you can use Eclipse, or you can use other softwares. But here we are using R Studio along with R. So this R Studio basic environment, generally once you invoke R Studio, you are going to see 4 types of windows by default. Four types of windows. We can customize these windows, either three windows or 4 windows. We can customize, but by default 4 windows you are able to see. First window, top left corner related to the script file. Top left corner related to the script file. Top left to bottom corner. Left to bottom corner related to the console interpreter shell type command. Right top window consists of tab folders, environment, history, connections, tutorial. Right bottom window, files to plots to packages, these available.
Sir, Krishnapasad garu.
Sir.
Sir, good evening, Dr. Rajendra.
Okay, sir.
Sir, I think it is not visible. It's only the PPT is visible for the participants.
Okay, sorry. Just now I shared this. Open.
Yeah, you share the screen share, Jen.
Okay.
Yeah.
Now is it visible?
Yeah, right. You please proceed.
Okay, thank you. So by default, whenever you invoke R Studio, you are going to see this type of environment, 4 windows, default 4 windows. So now we'll start a new project. So new directory, I'm selecting new directory, new project. Narayana Engineering College. Now you observe. So we started new project. This is the, I think are able to see this cursor.
Yes, sir.
So here, this related to the minimize, maximize. Here, data set, predefined data sets are there, and even our external data sets also we can use. Both options are available. Now we'll see. Suppose if you want to see the existing data set, how to see the existing data set? Any one of you, please? How to see the existing data set? So this is the run command. So library of help is equal data set to see the existing data set. I think data mining softwares like Veka, data miner. In this way, several mining softwares in the predefined Veka software, whatever predefined data sets are there, all data sets available even in R also. So these are all existing data sets. These are all existing data sets. Simple example, we start with one example, empty cost. Existing data set, empty cost is there. Here auto text is there, just you observe, view. I started with this lowercase letters, but view command required capital letter, initial cap. View empty cost. Empty cost is the existing data set. So now we are trying to see the empty cost data set. This is our data set. So we see few commands related to the empty cost data set. So cost data is equal to empty cost. So now I'm trying to split the data set. First, we try to understand the data set first. How many observations are there? How many attributes are there? What are dependent variables? What are independent variables? How to identify the dependent variable? How to identify the independent variable? Again, here also plays important. Normalization plays important. Which are feature attributes? Which are not feature attributes? So car dt is equal to empty car. Car dt is equal to empty car. You observe right side environment, car data. 32 observations of 11 variables. 32 observations of 11 variables. So all records we are not able to see at a time. And 11 variables, what are those 11 variables? How to see the structure of data? STR of car DT. By using the STR command, we can see the structure of the data. So these are the 11 variables. This car data, empty car is it's like a data frame. MPG, CYL, DISP, HP, these are the attribute names. MPG is a numeric data type. Values are like this. In this way, we are able to see at least a basic idea we are able to get from this structured data. And to see the content also, to see the content, we can use the head command. Head of car data. So this head is by default 6 rows we are able to see. Head is the command to see the top 6 rows. So top 6 rows we are able to see. Or you can use suppose if you want only 2 rows or 10 rows, we can specify the number. So top 2 rows. Even tail is also one command to display last 6 rows by default. We can use number also. So in this way, you can use n number of commands. We'll see. One second. I'm opening new file, new script. You observe a new file. Project is same project. Within that project only, I am creating one new script file. Okay. I have already code. That code I'm copying. Copy paste. You observe empty cost data only I have taken. Empty cost data. Here I used, okay, core data I used. Now you can find environment you observe. Again, car data, one more variable created, car data. Head of car data, displaying first 6 rows. Tail of car data, displaying last 6 rows. STR to see the structure of data. Histogram. One second. Previously, I created a few plots because of that this error is coming. So whenever any error occurred, we can go through the help file. Because by default, previous old data is available that need to erase. By using plot.new, we are eliminating the previous data. So car data $mpg. Here this mpg is miles per gallon is the numeric data. Miles per gallon is a numeric data. We created a histogram. What is the purpose of histogram? Here we are trying to use some visualizations. Okay. Before going through this, just we'll see demo of graphics. What type of symbols we are going to see? One second. You observe this right side bottom window. So plotting, scatter plot, pie chart, box with splitting, box plot analysis, maps, So bar chart, boxes, topographic images. So in this way, several visualization options are there. Several visualization options are there. What is the purpose of these visualizations? Why we are using this? Now we see the histogram. So you observe previously an image, one more image created. Histogram main purpose is by using this histogram, we are able to identify, is there any missing values? Is there any outlier? Is there any outlier? These visualizations gives more clarity, easy understandable. Another one is box plot analysis. You observe this box plot analysis. In data mining, 5 summary data is there. In the same way, here also one summary data. We'll say output of summary of car data, $MPG. So what is the use of dollar? Generally, in our database terminology, table dot column name we are going to use the table dot column name. But here, table refers to data set. Car data is the data set. Dollar is the separator between the data set and attribute. Dollar is the separator. In place of dot, we are using dollar. So summary of car data $MPG. So MPG data, you observe bottom window. Minimum value, first quadrant, median, mean, third quadrant, maximum value. Minimum, first quadrant, median, mean, third quadrant, maximum value are there. So this box plot analysis, box plot gives information related to the minimum value, maximum value, first quadrant, third quadrant, median. So this line, you observe minimum value 10.40. 10.40 is the minimum value. Maximum value 32 is the maximum value. So that 32. Third quadrant 22.8. First quadrant 15.43. So box starting is first quadrant, box ending is third quadrant, middle is median, first base starting point refers to the minimum value, base ending is maximum value. So this box plot analysis, box plot shows the minimum, maximum, first quartile, third quartile, and also the median values. So density refers to distribution. Density refers to the distribution. So car data $MPG. Whatever the miles per gallon data is there, MPG data, that MPG data, how it is distributed, that we can show as a plot form. So MPG data scattered from lowest to highest. So this related to these distributions, We'll see one more PPT, then we'll come to this. Are you able to see this PPT?
Yes, sir. Yes, sir.
Yes, sir.
Okay. Few concepts, statistical concepts we'll see, then again we'll move to the demo. So this already we discussed the 4 types of analytics. So this data mining process you can use in KDD format, and different methods are there. So types of data generally statistical point of view, types of data you can why I'm focusing types of data. Based on the data type, we need to choose the visualization technique. We need to choose the model also. For data analysis point of view or data analytics algorithms point of view, you may see clustering, classification, association, supervised learning, unsupervised learning, regression model, auto-regressive model. And you say different models are there. Which model I need to choose for my data set? That is depending on the type of data. If your data is related to the nominal data, one type of model, and your existing data is continuous data, and your dependent target data is a categorical, one type of model. How you are comparing? What are dependent variable? What are independent variable? Type of dependent variable, type of independent variable. All these matters. So here types of data you can categorize into discrete, continuous. Discrete, it may be nominal and ordinal. If it is continuous, this generally continuous, it's numeric data, either interval or ratio type, So qualitative data, quantitative data. Even in our college, AICTE, NAC point of view, qualitative data, quantitative data. Here quantitative, numeric, measurable. Qualitative. Here also measurable is there. That measurable is related to the nominal data. It contains some information, not a numeric data. It may be related to the grading, some ordinal data like ranks, qualitative data like excellent, very good, good, satisfactory, poor. In this way, qualitative measures are there, not with numerical terms, This we call it as qualitative, non-metric. Quantitative, metric, interval and ratio data. Interval data. That means interval data in the sense, period, duration is there. 10 to 20, 21 to 30. Ratio data. So to understand what is this qualitative, nominal attribute, ordinal attribute, just a simple one example, quality of life. Quality of life refers to, they given options also, scoring, poor, fair, average. So quality of life related to nominal, ordinal. Quality of life is related to the ordinal, ethnicity related to nominal, race related to the nominal, BP related to the continuous, So these are the different types of data. Based on the type of data also, we need to choose the model, we need to choose the visualization technique, statistical part also. Frequency distributions. Here, these numerical presentations, either individual or frequency distribution, continuous distribution. So descriptive statistics is used to describe the data, statistical inference. So this descriptive statistics comes, one of the thing is measures of central tendency, measures of dispersion. Measures of central tendency consist mean, median, mode. Measures of dispersion consist standard deviation, variance. So central tendency gives an idea about the concentration of the values in the central part of the distribution. So mean, average value, median, midpoint. Mean is different, midpoint is different. Mode, most frequently occurring value. Mode is the most frequently occurring value. So this is the mean calculation part. Number of sum of all elements by number of elements. Weighted mean, trimmed mean. Even in this mean also a different option. For each and every value, some weight assigned. Based on the weight assigning also again you need to calculate. Or trimmed mean. Trimmed mean means you can ignore left side two values L trim, or maybe trimmed mean of 2. That means left side, right side 2 values ignoring, and then calculating the mean. These are different options are there. Median, middle term. Mode, frequently occurring term number. Measures of dispersion. Here, this dispersion, sorry, spelling mistake, not depression, dispersion. Standard deviation, variance, range, interquartile range, coefficient of variation, these we can use. Here, range refers to minimum value and maximum value. Variance, square root of mean. Standard deviation, in this way, formula is there. Here, quartiles, deciles, percentiles. Here, quartile refers to 25 percentile. Deciles refers to 10%. Here, percentile, you can specify the number. It may be 15 percentile, 5 percentile, 28 percentile. In this also you can choose. Quartiles, 4 equal parts, Q1, Q2, Q3, Q4. Deciles, 10 equal parts, D1 to D0, D1 to D10. Specific percentiles, 5 percentile, 28 percentile. In this also you can use. So, for testing point of view, you can use a regular test or randomized test. So, regular test mean, randomized test mean, if you see there's some difference, maybe you get. So, coefficient of variation can also be used to compare variability between different measures. So, this is a sample data. A's frequency is there. So, percentile, cumulative frequency, cumulative percentile. Set tails refers to entire data converted into only 3 parts, 3 equal parts. Set tails 3 equal parts. Quartiles 4 equal parts. Quantiles, you can specify number. So in this visualization, histogram is one of the things for specifying the breaks data. Bar chart, univariate analysis, simple bar chart, line chart you can use. So here we are considering only one column. So this we call it as univariate analysis. Univariate analysis, only one column. So pie chart, stacked chart, only one value, univariate analysis. Box plot analysis. So box plot already we discussed. Now understanding the bivariate analysis. So here univariate analysis, bivariate analysis, so multivariate analysis, this is most important. Univariate analysis, pie chart, box plot, histogram, bar chart, this univariate analysis. So this shows univariate analysis within that variable, within that attribute. Is there any missing values? What is the minimum value? What is the maximum value? What is the tendency? This we are able to identify. Coming to the bivariate analysis, you required some analytical part here. You observe categorical versus categorical variables. Here, weekday, date. So, categorical tables. Categorical versus continuous variables. Categorical versus continuous variables. Bivariate analysis. Continuous versus continuous variables. Continuous versus continuous variables. Multivariate analysis. Scatter chart. Multivariate analysis. Scatter chart. So even in matrix also you are able to say diagonals always one. Continuous versus continuous variables. Correlation. Shows the correlation. COR one function, COV one function, COR correlation, COV covariance. So this COR, COV shows the relationship between the attributes. Relationship between the attributes. Multivariate box plot analysis. Density plots. Variable values, how these values are distributed. Inferential statistics. So based on the descriptive stats, based on this, we need to draw the conclusions. Inferences. So to work out inferential statistics, we need to identify whether the data is correct or not. So here for validating the data for corrections point of view, different types of statistical testings are there. Generally, possibilities type 1 error, type 2 error we are able to get. type 1 error, erroneous, retain H0, rejecting. So hypothesis testing is also called as significance testing. So this hypothesis testing point of view, null and alternative hypothesis, test statistic, p-value and interpretation, significance level. So different types of statistical testings, different types of methods are there. So if in bivariate analysis, suppose if it is continuous attributes, that means feature is continuous and even response is also continuous, then go for Pearson correlation. Feature is continuous and the response is categorical, go for either p-test or ANOVA. ANOVA refers to analysis of variance. And feature is important. Feature attribute is categorical and continuous attribute response, then go for an ANOVA. Both are categorical attributes. In that case, go for chi-square test. So generally, this correlation shows the association between two or more continuous variables. That means correlation shows the relationship between the attributes, relationship between the attributes. Either is it a strong relation, positive relationship, or strong negative relationship, or no relationship between the attributes. No relationship between the attributes. So that can be identified by using this COR function. So correlation close to 1, strong positive relationship. Correlation close to negative -1, negative relationship. Close to 0, no relationship. You observe. Is it okay? Shall I continue? Hello?
Yes, sir.
Hello?
Yes,
Sir,
sir.
please, sir, please continue, sir.
Yes, sir. Yes, sir.
Okay.
You continue.
Here, two variables are there. One related to the guest variable, another one is the bottles of water.
No,
So
please.
mapping for these two variables, and related to the transaction, day of month, bank account balance. Another maybe driver color of the eyes, petrol used. You observe student marks, there may be some relation. Student items purchased may not be no relation. Customer purchasing the items may be some relation. Customer software used in project, no relation. In this way, based on the common sense, based on the data availability, based on the COR, COV values, we are able to identify the relationship within the attributes. Relationship within the attributes. So chi-square test generally we can apply on if both are feature attributes and response attributes both are categorical, then go for chi-square test. Then go for chi-square test. Z test or categorical and continuous are there. In that case, either go for either Z test or ANOVA. Go for Z test or C test or ANOVA. Here, I'm not going in detail related to the statistical testing techniques. Just summary I'm giving. With few case studies, examples. We'll see. Example also, demo also we'll see related to this on empty car. If continuous versus categorical, then go for ANOVA. So in this way, one sample t-test. Here, one sample t-test in the sense, only known figure. In that case, we go two sample t-test, sample 1, sample 2. Two samples are there on that applying t-test. Paid test, paid t-test. Here, you to know more about this sample 1, sample 2. Here, one sample in the sense is the mean height of female college students greater than 5.5 feet. Here you observe, we are comparing with the numerical value. Is the mean height of female college students greater than 5.5 feet. Here, feature attribute is female college students height. Comparing with the 5.5 numeric. So this we call it as one sample. This we call it as a one sample. And see the another one, two samples. Does the mean height of female college students significantly differ from the mean height of male college students? Here you observe two sets of data is there. Sample 1, sample 2. Sample 1 is female student height, sample 2 male student height. So here two samples involved. Two samples involved. Paid. If you measure the weight of male college students before and after, each subject takes a weight loss significant enough to conclude that the pill works. So paid test. Paid in a sense linking. Even in healthcare also you can see patient test before food or after food. Even in our education student analysis point of view also, before course starting or after course starting. Before course starting, what is this measure? After completion of that course, what is this measure? So this we call it as linking paid test. We'll see one example related to the student score marks. Student score marks. So t-test regression output are high school SAT test show significant predictors of college GPA. T-test regression output. Here, question is related to the two predictor variables. Two predictor variables. T-test regression output. Expected SAT test score, expected GPA score, expected NAC grade, expected NBA score. We applied for both NBA as well as NAC. So expected scores, t-test regression output. So parametric test. These most important two independent sample t-test, two dependent sample t-test, one way ANOVA. This related to statistics for terminology, population sampling. Population refers to entire data, entire thing. Sampling, subset of that entire population, entire population. Why sample is required? So I'm skipping related to this sampling because generally from qualitative data only we are going to get qualitative results. If your sample is not up to the mark, if your sample is data is not 100% accurate, we are not able to get the qualitative result. So qualitative result is depending on the qualitative data. So sample is 100% correct, we are able to get effective results. So types of sampling, collecting the data. Maybe million records are there. Within that million records, instead of using the million records, we are going to randomly take few sets of data on either 10,000 records or 1 lakh records, applying the testing. So probability sample, non-probability sample, these I'm not concentrating, I'm skipping this sampling. So different methods are there to collect the sampling. Random sampling, cluster sampling, multi-stage sampling. These important. These also, okay, we'll see later. We'll move to statistical purpose measure. So by using box plot, histogram, or scatter plot, we are able to identify the outliers. Outliers is not part of the statistical analysis. That we need to eliminate. Then only we are going to get accurate results. So to identify the outliers, you can use a box plot, or histogram, or scatter plot. Once you identify the outliers, you need to delete those records. And sometimes you may find missing values. So data cleaning out, handling the outliers, handling the missing values. So this is a part of data cleaning, data pre-processing. Handling missing values itself is a research subject. Identifying the missing values and adding or keeping some appropriate value is also one of the steps. So for that, smoothing, binning, different options are there. Missing values treatment. So missing value related is there. Simply one option is deletion or imputation. If it is deletion, what we need to delete? Deleting the entire row. Or link is there, pairwise deletion, or deleting that particular entire column. These are the three options. Imputation. If it is a time series problem and data without trend and without seasonality, use either sample imputation like mean, median, mode, or random. If data with the trend and without seasonality, linear interpolation you can use. Data with the trend and with the seasonality, seasonal adjustment you can use. General problem, if it is categorical, we can use some multiple imputation. Filter method, wrapper. So just skipping 2 slides. We'll move to immediate part. Next concept is regression. This will move to regression refers to the study of analysis of dependent and independent variable. So machine learning algorithms, different types of machine learning algorithms. This table is most important. Just you observe before going to the regression part. Just this table. After studying this table, we'll move to the regression part. Machine learning types. So it may be supervised learning or unsupervised learning or semi-supervised learning. If your target variable is continuous, go for regression. Categorical target variable, go for classification. Unsupervised learning, you don't know the target variable. That means there is no class label. There is no class label. Go for clustering. Semi-supervised learning, if it is categorical target variable, classification or clustering. So by using this, some notations are also, we are able to identify which model is suit for our existing data. Predictor variable is continuous and response variable is continuous. Go for linear regression or neural network. Predictor variable is continuous and response variable is categorical, logistic regression or neural network. Anyway, some mathematical theorems, mathematical steps are there to choose the model. Now we'll see the linear regression. So linear regression, it's like y is equal to mx plus the simple slope intercept form. Slope intercept form, mathematical terminology point of view. So this regression shows the relationship between the attributes. If it is a simple regression, y is equal to b0 plus b1 into x. So one dependent to one independent variable, one dependent to one independent variable. Multiple regression. In that multiple regression, multiple independent variables. So the y value is depending on more number of attributes. Then we go for multiple regression. The product price is depending on manufacturing cost. Product price is depending on manufacturing cost. It's simple regression. Product price is depending on manufacturing cost, advertisement cost, storage expenses, profit. In that case, we call it as multiple regression. So the y value is depending on multiple attributes. Y value is depending on multiple attributes. This we call it as a multiple regression. Multiple regression. So I think most of the people know height and weight relationship. As height increasing, weight also increasing. Height increasing gradually, slowly, weight also increasing. So based on this, next height, what is the weight? We can predict. Suppose for 180, weight is 60.
Sir, Krishna
For
Prasad, sir.
190.
Sorry to disturbing you,
Yes.
sir.
Yes, sir.
Sir, 2 minutes, sir. Just we will
Okay,
take
okay.
one snap, sir. Just all the participants, please switch on your video for a minute so that we will capture one picture for our report purpose, please.
Sorry, I'm not able to switch on my camera.
Okay, sir. So those whoever possible, please, maximum people, please try to switch on the videos.
can I stop the sharing?
No problem, sir. The sharing is also okay. No issue, sir. It's sharing, we will take that. Okay, sir.
Sir,
Okay.
Okay, sir. Continue, sir.
1 minute, sir.
Sir.
హాయ్ ప్రియా ఏ నేను కనిపిస్తుంది నువ్వు రారా కనిపించలేదు
1 minute.
Sir, తీసినారా స్నాప్?
Okay, sir.
ఓకే, ప్లీజ్. సార్ కృష్ణప్రసాద్ సార్,
సార్
మధ్యలో దీనికి డివేట్ అయి ఉన్నారు. ఒక డెమో ఏదో చూపిస్తా ఉన్నారు.
వస్తున్నాను.
డెమో నుంచి మళ్ళీ వచ్చేసారు, పూర్తిగా థియరీలోకి వచ్చేసారు. ఇంకా
నెక్స్ట్ సెషన్ ఇస్ దట్ ఈస్ రిగ్రెషన్ ఓన్లీ.
ఓకే, డెమో చూపిస్తున్నారు కార్ డేటాని.
అవును. ఫర్ దట్ రిగ్రెషన్ ఈస్ రిక్వైర్డ్, రిగ్రెషన్ కాన్సెప్ట్ ఈస్ రిక్వైర్డ్.
Okay, sir, please proceed.
Immediate after this regression concept, we'll go to the demo session.
Okay, since we have only 50 minutes of time.
Okay, sir, I understand.
Okay, please go ahead. Dhananjay sir, good evening.
Dhananjay, sir.
So this is related to the height and weight. So this, by using this existing data, we can draw some inferences. So suppose for 180 centimeters height, weight
Please
is some,
share the screen, sir.
Sir, we're not able to see the screen.
Yes, ma'am.
yeah, sharing.
Yeah.
Is it okay?
Yeah, okay, sir.
It is okay.
So this is the relation between weight and height. Based on this, we can able to predict. So regression mainly of two types: simple linear regression, multiple linear regression. So regression analysis is the statistical process for estimating the relationship among variables. So linear regression, multiple linear regression, logistic regression, one more is there, so that we are not concentrating. Example, salary experience, simple linear regression. You can go for even ordinary least squares also for this type of simple linear regression model, R square model. Now we'll see demo, adjusted R square. So now coming to the demo, this is our car data. So this is the structure of car data. We have taken existing data set. So in help also we can see the structure of data. Here empty cars is the existing data set. Motor trend car road test data. Motor trend car road test data. MPG miles per gallon. Number of cylinders, displacement, gross horsepower, rear axle ratio, weight. These are the attributes. 11 attributes are there. 11 attributes. So now we are trying within this miles per gallon is the most important attribute. So this miles per gallon is depending on other set of attributes, depending on auto gear and manual gear. So this is the density of car data, MPG data. Now we are trying to create a subset within the car data. By using car data, we are trying to create two subsets. So one is related to the auto gear data. Another one is a manual car data. Auto. Here you observe this. AM transmission. 0 is equal to automatic, 1 is equal to manual. AM is if it is 0, this we call it as auto cars. 1 we call it as a manual car. So we created a subset. Auto car is equal to subset of car data, comma car data $AM is equal to 0. So we created a auto car. Now we'll see what is auto car. You observe auto car, 11 attributes are there. 11 attributes. We'll see this. Auto car, 19 observations of 11 variables. 19 observations of 11 variables. What is the size of car data? Number of rows are 32. Number of rows are 32 for car data.
Yeah.
For auto car, 19. You can use n row, n column, all these functions. Now I am creating manual car. Manual car. Now you observe environment, manual car. 13 observations of 11 variables. 13 observations of 11 variables. So now we'll see the manual car. AM is equal to 1. We created a two samples, two subsets. So one is auto car, another one is a manual car. Now we are trying to conduct a t-test on this. Already we discussed when we conduct two tests, t-test, we'll conduct a t-test if it is two subsets are there. In previous example, while studying, in PPT also, one sample test, two sample test, t-test. T-test will conduct between two subsets, two sample data sets. So we are conducting t-test. So here, this shows the difference between these two. You observe t-test, DF value, P value. This P value, alternative hypothesis testing point of view, this you can use. So we'll construct a plot on car data $MPG and car data $HP. So we are trying to identify the relationship within the attributes. So MP related to MPG, what are the other attributes? So this MPG value is depending on HP also. So are any other attributes are there? MPG miles per gallon. This getting the number of miles, increasing the number of miles is an adjustment. So now we are trying to find the correlation within the car, empty cars. Correlation within the empty cars. Now you observe this correlation. COR is the function. You observe MPG1, MPG CYL minus value, negative value, MPG DISP minus 0, MPG HP minus 0.7. So here, if it is positive correlation, positive value close to 1. If it is negative correlation, negative value close to negative value. If it is 0, no relationship. So based on COR function, we are able to identify attributes related to the MPG. So we created a here this miles per gallon MPG value is depending on multiple attributes. MPG value is depending on multiple attributes. So HP, W, WT plus AM plus CYL. So these many attributes are depending on MPG. So MPG are depending on all these attributes. So we created a multiple regression model. We created a multiple regression model. So we can, this is regression fitting model, car data, REG regression fit. LM is the linear regression model. LM is the linear regression model. MPG, this is dependent variable, tilde character. If it is only one attribute, simple linear regression model. Multiple attributes, multiple regression model. HP, WT, AM, CYL, multiple values are there. So this is formula we applied a linear regression model. MP is tilde HP plus WT plus AM plus TYL. Data is core data. So residual here, this residual error or residual this related to this one second. I'll show. Okay, this. So we constructed a multiple regression model. Now we'll see this summary of this. So residual error is significant code. Residual error 2.53 on 28 degrees of freedom. Multiple R squared 0.8399. So p value is 2.908. So we'll see, this is the model we constructed. Now we'll see on test data. We'll try to use this linear regression, multiple regression model for prediction point of view. So for prediction point of view, we are constructing a test data. So one test data is the core data 10 to 14. Here in core data, how many observations are there? 32 observations. In these 32 observations, we are considering 10 to 14. That means 5 records only. So in the test data 469, this we considered. So with that, we are trying to predict. So these values, MERC 280 possibility is 19 gallons, 19 miles to. MERC 280C 19.49 gallons to 450 15 point. So previous based on this test data, we can predict based on the type of car. So this is one simple example related to the multiple regression model. Now are able to see these slides? So in this way, we can use regression model, linear regression model, simple linear regression, multiple linear regression, logistic regression. This is related to the exponential. Auto-regressive model. If it is continuous variable, dependent variable and independent variable are both are continuous time series, then go for auto-regressive model. If time permits, we'll see one more example.
Krishna Prasad, sir.
Sir.
Thank you very much for sharing your knowledge. If we have time, it's my humble request, if possible, please spare 1 hour of your time tomorrow for practical sessions. Then you can add what are all the other topics that you want to explain. If it is possible, let us stop it today. If not possible, continue with your session for a few more minutes.
Okay, just one example. I will show one example related to the car data only. Just
okay, if it is possible tomorrow or day after tomorrow, if we can spare 1 hour of time, let us stop it today. If it's not possible, please continue. Tomorrow or day after tomorrow.
Tomorrow, okay. Day after tomorrow also I have possibility.
Okay. Then.
Okay, within this, any queries first?
Okay. From participants, audience.
Any queries? I think you understand the types of data.
Yes.
Types of models.
Yes, sir. Yes, sir. Understood, sir. Sir, any possibility to share the presentation slides, sir?
Yeah, I'm going to share. I will send this PPT code, everything to your organizer.
Okay, sir. Sir, and one more information, sir. Sir, whether this regression is used for load stress, sir, in the software industry?
Yes, we can use.
Okay, sir. Thank you.
And one more thing, research point of view also most important. High dimensional data you observe. Wherever high dimensional data is there all statistical formula you need to rebuild.
Okay, sir. Clear, sir.
Any queries from audience?
I think I'm Dr. Dhananjay.
Sir. Yes, sir, please.
Yeah, I think the Dr. Krishna sir has prepared excellent ground of descriptive statistics and predictive statistics or inferential statistics. I think this is a nice summary. I think it helps me to speak tomorrow to elaborate on this inferential statistics some more for a somewhat more statistical perspective, because I'm not an R programmer. SAR has given excellent ground on how to make decisions using these statistics. Thank you.
Okay, thank you, sir.
Yeah, let me add one more point to this, sir. Good evening, sir, Dr. Dhananjay, sir.
Please, sir. Please, sir.
Yeah, regarding coming to the tomorrow's session, This will be going to handled by Dr. Dhananjaya,
Yes,
Dean
sir.
of MBA. Really, it's going to be a more exciting session tomorrow, since Dr. Dhananjaya sir is an alumni of IIM, a brand for MBA. He is a man of branding. He knows very well about how to showcase things. So analysis and visualization is very, very crucial for any business to grow well. So Dr. Dhananjaya Gangareni is an expertise in data analysis as well as visualization. So he is expertise in statistics. In other words, he is a good statistician. So I request all the participants, don't miss tomorrow's session. I would like to add, yeah, one more thing, sir.
Yeah.
I would like to call all the participants along with my friend. I would like to thank to all the participants along with my friend and classmate, Dr. Krishna Prasad, for sharing the knowledge. Sir Dhananjaya sir, we are excited for your session tomorrow.
Thank you, sir. No, I think
We are
Dr.
expecting more statistics than our programming or some other things. How to showcase things well.
Yeah.
That's
I
what
think
we need.
yes, I think Dr. Rajendra sir is the better branding. His marketing and branding is FDP program.
Sir, మీరు దానికి మార్గారు.
Thank you, sir.
మీ
Thank
ముందు
you. It's
నేను
very nice
మాట్లాడితే
session.
హనుమంతుడి ముందు
No,
కుప్పలు
not
తెలిసినట్టు
like
మీ ముందు మనం మాట్లాడడం. ఓకే.
Not like that. Thank you very much. Thank you.
Krishna Prasad sir. Please try to handle 1 more hour and day after tomorrow.
Okay, sir. Definitely, sir.
Bhasha sir, please
Sir,
conclude. Or
yes.
is there anything from the side of Krishna Prasad or from the participant side?
Any queries? First, if any queries, we will address. Otherwise, we will close the session. Thanks for giving the opportunity. Thanks to Rajendra Garu, Bhasha Garu, and its entire organizing team. Thank you.
Thank you, sir. Krishna Prasad sir. Thanks for your valuable information regarding statistical analysis, as well as with demo session. And I hope all the participants are having clear about the topic, today's topic. So from the audience, no queries. Okay, sir. Thank you very much, and thank you very much for all the participants for your patient listening and supporting our FDP. Even though it is a hard time, but you people are staying with us and patiently listening the information. Thank you one and all. And okay, Krishna, once again, I wholeheartedly thankful to our resource person, Dr. Krishna Prasad sir, for sharing his valuable information to all of us. Thank you, sir.
Okay, Master. Thank you.
Thanks for all and all. Good night.
Yeah, good night. Thank you, sir.
Thank you so much.
Thank you, sir. Thank you so much, sir.
Okay, sir, we can leave them.